Hello students, welcome back to my channel. Today we are going to do class 12's chapter relations and functions, and the topic is types of functions. So before we go to types of functions, I just want to recall the concept of function from class 11. So function is one kind of spatial relation where some of the things are not different but spatial kinds of a relation. So it is called a well behaved relation. Okay, now look at these two figures. Suppose this is A and this is B. Think about A has 4 elements like this, and B has 3 elements. Okay, it can have more than 3 elements, 4 elements, whatever. Suppose B has a subset. This subset's name is suppose X. B has another elements like this. So these two relations can be defined. Now I'm drawing how these are related. Okay, you can see that all elements of A, all elements, okay, they all are being operated or being functioned. All elements of A are related. This is number one. Number two, for all elements of A belongs to capital A has a unique image in B. Okay, you can take any one of the element from A, you will be getting unique image of that in B. Okay, look, first one having this, second one this, third one this, fourth one this. What does it mean? It means no elements will have two images. Okay, so these two are the conditions for being, means for a relation to be a function. Okay, now from this, set A is the domain of the function. Okay, then set B is the codomain of the function, and set X is the range of the function. Okay, range is the set of all images, not the whole second set. Whole second set is the codomain set. Okay, I hope everybody knows it now, and we all have done in class 11, 12 both. Coming to the types of functions, the main topic today. Okay, so it's number one, one function, or you can say injection or injective function. So this is the first category. Now its definition. A function f such that a to b is said to be a 1 1 or injective if different elements, that means any two different distinct elements, okay, if distinct elements of A have distinct images in B. This is the definition of 1 1 function or injective function. Okay, I'm repeating. Look, one thing, if such that A to B is said to be a 1 1 or injective if distinct elements, that means we will take two different elements of A have distinct images in B. Okay, now look for this. I think you can see for this first and second, if we take these two different elements, we will be getting same image. It means it is not 1 1 for sure. Okay, this is not 1 1 because distinct element if we are taking, we will be getting distinct images, but here it is not done. So we this particular example is not 1 1 function. Okay, now mathematically we can say that if such that A to B is 1 1, if and only if in place of if and only if you can write down implies and implied by like this. A not equals to B implies f of A not equals to f of B for all A comma B belongs to A. That means if two distinct elements we are taking, they are not equal, same, then their images also will be different. Or if their images are same, like this, if their images are same, the elements must be same. This also can be written. So these two, one of these two, anything you want, you can write as its mathematical expressions. Okay, this one is if the images are same, then the elements must be equal. Okay, for example, let A equals to 1 2 3, B equals to 1 2 3 4 5, and if such that A to B be a function defined by f of x equals to x plus 1 for all x belongs to A. This is the definition of this function. So what will be the elements? The elements will be look, f of 1 equals to 2, f of 2 equals to 3, f of 3 equals to 4. That means the elements will be 1 comma 2, 2 comma 3 and 3 comma 4. Now you can see clearly that 1 2 and 3, all three different elements have three different images. No elements are having same images. Every element is having different images. That means this is 1 function. Okay, this is 1. Now there are some of the questions that we have to do, or we have to check the 1 whether the given function is 1 or not. So we will do that. An example can be done. So suppose the question is that if such that z to z integer set, okay, and it is defined by fx equals to x square plus 1 for all x belongs to z. Okay, z is integer set of all integers. Okay, we have to check whether this function is 1 or not. How we will do it? First we will take any two elements from domain set. Here both are same, so z. Let x comma y belongs to z be two arbitrary elements for which we are taking it that for these two their images are same. Now look, the first condition that we wrote with inequality also can be taken, but for proving it, verification process, we need the equality conditions. That's why we are doing with the second one. So f of x equals to f of y, already we will take it as condition. Now we will write its values. X square plus 1 is equals to y square plus 1, right? Because f of y is equals to y square plus 1. From this we can get x square equals to y square. From this we can write down x equals to plus minus y. Okay, x equals to plus minus y, that means it's not unique, right? We must have x equals to y only. Then we can say that function is 1. So here we are not getting unique solution. So therefore we will write the answer like this. As f of x equals to f of y does not give a unique solution, x equals to y. Unique solution must be x equals to y, not x equals to plus minus y. F is not a 1 function. Understood? This is the way you have to do. First you have to take fx equals to f of y. From that you need to go to the step anyhow x equals to y. If you are not getting x equals to y, that means f is not a function of, f is not a 1 function. Our next category is many one function. Many one means the figure that I have drawn. Okay, many into 1, that's why it's many one, and 1 into 1, that's why 1. Many one means suppose this is A and this is B and this is F. So a function f such that a to b is said to be many one if two or more elements, it can be more also, two or more elements of A have same image in B, then it will be called as many one function. The first figure that I have drawn in the beginning of this session, that is also many one function. Okay. Our next category is onto function or surjective function. Okay, now onto function, what does it mean? Onto function means such that suppose A to B is a function, then this will be called onto or surjective if all elements of B, for all y belongs to B, all elements of B, there exists an element in A. That means we can say that all elements of B has pre-image in the set A. Okay. In other words, we can say that means f of the whole set A, f of the whole set A is equals to the whole set B, or we can say that range of f equals to codomain of f. Now there are figures that I am drawing. Let me focus it. Yes. 1, 2, 3, 4. Okay. This is A, this is B, this is F. Okay. Suppose these are related like this to this to this to this, and this one to this one. This is obviously 1 1. Then this is many one. This is onto. You can see all elements are having pre-images all elements of the second set. This is onto function. You can see here also all elements are having pre-images and all different elements have different images also. That means this type is 1 1 and onto, and these two together, if both the function is 1 1 and onto simultaneously, then it is called bijective function, or we call it as bijective mapping. Okay, function can be called as mapping also. So for being bijective function, we need to prove, or we need to check whether the function is 1 1 or onto both together or not. I have taken one question for you so that you can understand how it will be done, especially when you are getting these type of questions. Look, let A equals to capital R minus singleton set 2 and B equals to R minus singleton set 1. Now, if such that A to B is a function defined by f of x equals to x minus 1 divided by x minus 2, we have to prove that f is bijective. That means we have to prove f is 1 1 and onto both. Let's do it. So for 1 1 first we will do. Okay, for 1 1, what I told, for 1 1 you have to take, let x and y be two arbitrary elements from the domain set such that f of x equals to f of y. Okay, we have to take this calculation and we have to go further. From this, x minus 1 divided by x minus 2 equals to y minus 1 divided by y minus 2. From this, x minus 1 into y minus 2 is equals to x minus 2 into y minus 1. Simple multiplication, xy minus 2x minus y plus 2 is equals to xy minus x minus 2y plus 2 plus 2 plus 2, xy will be cancelled out. So we are getting with minus 2x minus y is equals to minus x minus 2y. That means from this we can say x minus x equals to minus y. So we can say x equals to y. Okay, we have taken f of x equals to f of y. From that we have come to the point x equals to y. That means f is 1 1. Okay, now coming to its onto part. Okay, so we will be now verifying whether it is onto or not. For that we will take any element from the second set, that is B. Then we will be doing like this, f of x equals to y. Sorry for the interruption. So f of x equals to y, that is x minus 1 divided by x minus 2 equals to y. It implies x minus 1 equals to y into x minus 2. From this, if we find x, we will be getting x equals to 1 minus 2y divided by 1 minus y. I have not done the full calculation. You can do it. So x equals to this, and it is quite obvious that y not equals to 1 given in the question, right? Because the set B was R minus singleton set 1. That means no element from second set can be 1. So if y not equals to 1, that means this is a real number. Okay, so this is a real number. Now obviously this not equals to 2, because if we take this is equals to 2, then we will get 1 equals to 2. Okay, so this will not be equals to 2 also. So we can say that every element of B has pre-image in set A, that is X. Okay, so as we are getting this, that means we can say F is onto also. As F is 1, 1 and onto, so we can write down, therefore F is surjective. Okay, this is the way you have to do the whole question. First you have to verify 1 part, then onto part, and then you can write down whether it is surjective or not. Okay, so this is all about today's session, students. I hope you all have understood, and now you can do, or you can apply whatever we have discussed, this knowledge into some other problems from your book. So we will meet in the next session with any other topic. Till then, have a good day.